All right, number 25, determine the intervals over which the function is decreasing, increasing, and constant. So just like we talked about with video number 24, the key question you want to ask yourself is, what is happening to the y values as the x values are getting larger? And if we read this graph from left to right, as you should, you read a graph just like a book, left to right, we can see that as the x's are getting bigger, so too are the y's. So let's see if that bears out. We can choose, how about this point here? That looks to be the point, -8, how about, looks like what, 3? And these are approximate, right? And we're just using this to illustrate the point here. And if we go up a little bit, how about we choose maybe this point here? This looks to be -1, +4. And if we go up a little bit, how about something like this? Approximately looks to be, I don't know, 9 and maybe 7, something like that. Well, we can see that as the x's are getting bigger, the y's are also getting bigger, aren't they? We go from -8 to -1, so that's an increase with the x's. And the y's also got bigger, right? They went from 3 to 4. So both the x's and y's are increasing. Here, if we go from -1 as the x value to 9, that's clearly an increase. And what happened to the corresponding y's? Well, we went from 4 to 7, again, increase. So this trend continues throughout the entire domain of this function. As the x's get bigger, so too do the y's. And so we can say that this function is increasing over its entire domain, and the entire domain written in interval notation would be from -infinity to +infinity. At nowhere on this graph is the function decreasing, and nowhere on this graph is the function constant. And so number 25, increasing -infinity to +infinity.